All right. Hi, I'm Bella Yedman. I am a junior at Villanova University. I'm studying biology, and I am one of the members of the Save Barnegat Bay Student Grant Program 2021 Bay Nettle team.
And I'm Alex Sellitsch. I am a junior at Stockton University studying marine biology, and I am too a member of the Bay Nettle Student Grant team.
So our project this year was focused on the water quality of St. Barnegat Bay and its relationship to the Bay Nettle population. So our project title is Bay Nettles and Lagoons, an assessment of water quality in Berkeley Shores and Silver Bay, New Jersey.
So our objective for this project was to determine areas of Barnegat Bay for bay nettle growth in the lagoonal communities and the reproduction of the bay nettles based on water quality conditions in lagoonal areas. So for the introduction of bay nettles, they're a species of stinging jellyfish very present in the Barnegat Bay area. Bay nettles thrive in lagoons where man-made bulkheads and floating docks provide structure for polyps to attach and grow and to eventually reproduce. Bay nettles prefer warmer waters and low dissolved oxygen levels, which are both concentrated and characteristics in lagoons. The Berkeley Shores and Silver Bay regions of Barnegat Bay are both highly developed lagoonal communities where bay nettles are likely to settle and reproduce. The study will investigate the difference in water quality among lagoons in Berkeley Township, Silverton, and Lacey Township to determine where bay nettles are more likely to settle and thrive. For our sites overview, we have various locations. So this map will show the outline of where our sites are. Up top is the Silver Bay community. Down in the middle are the Berkeley Shore lagoonal communities that we visited. And down at the bottom are our two control sites down in Lacey Township. For our Silver Bay sites, we had 6 locations. You can see we have 2 areas that are more inland. S2 is where we had a data logger, which we'll get to in a moment. And then over to the right, we had areas that were more exposed to the open bay. These are pictures that represent the sites that we went to. You'll see the asterisks next to a couple of locations at Cedar Tree and Aldo Drive. Those are where we had the data loggers. For the Berkeley Shore sites, we had a number of those. This is one area that was in the middle of our testing sites. We had a couple of areas that were towards the like lagoonal areas, and then one that was more exposed to the open bay, which you can see at B5. These are the pictures that represents our data testing sites. The asterisks again show where we had the data loggers down at B4 at Allen Road, and then down at B5 at Amherst Drive that was located at that open bay area. Here we have more of the Berkeley Township sites. You can see that we have a couple that are more closed off in the lagoonal areas, and then we had one that was more exposed to the open bay. Again, we have the pictures that represent where we had our testing there. We didn't have any data loggers at these testing sites. For our control sites, which were down in Lacey Township at Sunrise Lagoon, these areas here are where we had data loggers. We had one that was more exposed to the open bay, and then we had one that was more inland in the lagoonal area. And these are pictures that represent where we had our data loggers down in Lacey Township and our control areas. For our methodology, sampling was done every Monday in Berkeley and every Tuesday down in Silverton from June 7th to August 2nd. We had a YSI meter that was used to collect water temperature, salinity, conductivity, and dissolved oxygen. We had a sampling pool that was used to collect our water. We dipped the sampling pool 3 times in each sample, and then we collected our water sample. We would put it in the Whirlpack bags that you see down at the bottom, and we would also put it in plastic bottles to help with our testing back at the Eco Center. We had data that was collected for tidal stages that was recorded from the Beachwood Yacht Club weather station as well. In the lab, we were able to test for pH, turbidity, and chlorophyll. We were also able to test for suspended solids of each of the samples that we collected. The bacterial analysis for E. coli and other fecal coliforms were also performed using ColiScan method. The results for the total suspended solids were recorded, and then they were also measured the following day. This is a ColiScan that you can see with E. coli and other fecal coliform matter. We didn't test for any other matter in those samples. We were just strictly looking for E. coli and fecal coliforms. We would count each of the from each of the samples, and then we would record this. You can kind of see the dark blue is the fecal coliform and the E. coli is the dark pink. For our methodology, we also had, these are our data loggers. They're hobo pendant data loggers, and they were deployed at 6 locations on various dates, June 15th, June 2nd, and June 28th. And they were strictly to collect water temperature in those isolated and open lagoon areas. The data loggers were retrieved on July 27th and August 2nd. Here you have the map of where the data loggers were down in Silver Bay. And then this is our area in Berkeley. The B5A was towards the open bay and the other one was more inland. And then these are our 2 control sites down in Lacey Township.
And then I'll be talking about the results of our study. So the mean water temperatures that we gathered from the hobo pendant data loggers, they ranged from 26.9 degrees Celsius at control 2 to 27.6 degrees Celsius at S2 in Silverton. And we found from our results that all of the data loggers in open lagoonal areas had warmer water temperatures than those in isolated areas. So from the map, you can see that the distance to the open bay at B4 was 1.14 kilometers, and the distance from B5 to the open bay was only 0.08 kilometers. And this was surprising to us. We had originally thought that the isolated lagoonal areas would be warmer, but in a bit, we'll explain why we think that they were actually colder in the isolated lagoon. And the same thing here, S2 was our more open lagoonal area versus S3 was our isolated area just based on distance, even though these distances are quite similar. And then finally, again, control 2 was our more isolated area, while control 1 was more open to the bay. And again, control 1 was warmer than control 2. So yes, the warmer water temperatures were absorbed more frequently in the open areas versus isolated areas. But we think that because these open lagoonal areas were more shallow than the isolated lagoonal areas, heat could more readily penetrate through the water column and warm up the water more. And also based on one of our sources, bay nettle polyps are actually found more often in shallow locations in estuaries. And we think that this has something to do with that shallow locations are warmer. And because bay nettles prefer warmer waters, they would be more likely to found in open lagoonal areas than in isolated areas. And then I'll be talking about dissolved oxygen as well. So our dissolved oxygen levels range from 0.94 milligrams per liter, and I'm so sorry, I cannot see. All right, well. And we've had that Berkeley Shore South had the lowest mean dissolved oxygen levels, while Sunrise Lagoon had the highest mean dissolved oxygen levels. And Berkeley Shore South had dissolved oxygen levels that were significantly lower than the other 3 study regions based on statistics. So we have these heat maps here, and in the bottom right corner, you can see a scale with different color coding. So our locations that had dissolved oxygens less preferable for bay nettles were in green, and if they were more preferable for bay nettles, they would be in red. So this first map is of Berkeley Shores North, and you can see that most of the sites are quite preferable, or not preferable for bay nettles, especially B2 was not good habitat for them. And then, but in Berkeley Shore South, you can see that there are 2 red dots in the bottom and orange as well. So those would indicate more preferable conditions for bay nettles. This is the Silverton map we have, and these had more of a range. S2 was good for no bay nettles, but as you got closer to S4, S5, and S3, those were all also bay nettle population. And then finally, this is Sunrise Lagoon, where we have preferable habitat in control 2, but less preferable for control 1. And then here's just a map to show you, or a graph to show you how the different levels of dissolved oxygen compare to each other at the different sites. So because Berkeley Shore South had the lowest mean dissolved oxygen levels, we would say that this is preferable habitat for bay nettles. And Berkeley Shore South had very isolated lagoons, which you can see in this map right here. Pretty much all of the sites are isolated except for B7. So this would contribute to low dissolved oxygen as the isolated areas have more stagnant water, and this would result in less oxygen in the water. And then finally, we are going to talk about salinity. So salinity ranged from 12.8 parts per thousand at S1 to 25.7 parts per thousand at control 1. Silver Bay had the lowest mean salinity, and Sunrise Lagoon had the highest mean salinity. And each of the 4 study regions were statistically unrelated to one another. So here again, we have a heat map of locations based on preference for bay nettles. And so the Berkeley Shores North sites were all medium. In Berkeley Shores South, these were actually all anti-bay nettle. They're pretty good for having no bay nettles. But then in Silverton, you can see that these are all red. So these would be preferable habitat for bay nettles. And then finally in Lacey again, this is good for having no bay nettles. And here again, you can see a graph of how the different salinities relate to one another. So because Silver Bay had the lowest salinity of the 4 study sites, this would be preferable for bay nettles because they enjoy low salinity, but bay nettles also prefer areas of low variance in salinity, a narrow salinity zone, which Silver Bay actually had the highest variance in salinity, but Berkeley Shores North had the lowest. So we would predict that Berkeley Shores North is actually more likely to harbor bay nettles because of its low salinity zone, and it also has the lowest salinity above Silver Bay. So we concluded that the Berkeley Shores lagoons of Barnegat Bay should be focused on in more endeavors to minimize bay nettle habitat. Berkeley Shores South has low dissolved oxygen levels, and Berkeley Shores North has a low narrow salinity zone, and these both attract bay nettles and provide a stable habitat for them to grow and reproduce. So as already being addressed by the NJDEP, the Berkeley Township Underwater Search and Rescue Team, and Montclair State University, bulkhead scrubbing and floating dock removal should continue to be utilized in this region to minimize bay nettle habitat. And we also think that we should use the people that live in these lagoonal communities to spread awareness about the places they live, because everyone was very positive about us sampling and learning more about where they live. And we just have some more references. So thank you for listening to our presentation. And yeah.
Nice job, ladies. So I just have a question. Based on the information that you shared, obviously you were looking at very analytical data, very specific numbers that you were collecting from machines and scientific process. But I'm asking more anecdotally, did you see nettles in places where you thought they should be? And did you see less nettles in places where you predicted based on the data that there should be less of them?
We saw a lot of sea nettles in the Berkeley Shores region, and we actually did not see any in Silverton except for one time that we did. But towards the end of our study, we went to a woman's house and she lived on the open bay in Silverton, and she had a lot of sea nettle or bay nettles surrounding her property.
So you are concluding basically that where you think you should see them, you saw them, where you don't think you should have, you didn't.
Yeah, we pretty much saw exactly what we had predicted from our study.
Awesome. So another thing that you might add to the reason why you saw cooler waters in back lagoons could be from rainfall. Rainwater and groundwater is often cooler in temperature than bay water. So if those areas were inundated with rainwater most recently, they're going to see probably lower water temperatures than the open bay, which takes, obviously you were right, it's shallow and it can heat up, and also having less changeover of water would keep that temperature up high in the summer months. So would you like to add anything else about your experience with the student grant program, or anything that you were curious about? What kind of questions would you ask if you do this project in the future? Anything else you'd like to add?
So I really enjoyed doing this project, and it led a lot of questions, I guess, for the future. I enjoy seeing this pursued again next summer, specifically looking at that lady's house that we went to. She had such a large amount of bay nettle in that area, so I'm interested in why, as to either the flush of that bay in the area, like tidal ways, and then either researching a little bit further north to see if that has any effect either in Brick or in other Silver Bay or Toms River areas, just to see how the movement of the Barnegat Bay affects where the nettles go.
And I would also say that we would like to add some other parameters to better understand the bay and why the bay nettles would be found in different locations. Like Alex said, we would want to look at flow the next time the study was being underdone, because that could also affect where bay nettles are. But overall, I think this project was really interesting, and it's really good for everybody who doesn't enjoy bay nettles, because who does? So it's good to educate people and to get everybody interested in the bay nettle population and what people can do to minimize it.
Awesome. Nice job, ladies. I'll just add here for any viewers who are watching on YouTube afterward, thank you so much for watching. You can check out our website, savebarnegatbay.org. You can ask questions about this presentation and any others that you find on our YouTube channel by sending an email to education@savebarnegatbay.org, and we will contact the students with these projects or the scientists, mentors that were behind these student grant awardees. You can learn more about the student grant program at our website, clicking on the word educate and then scrolling down and finding student grant. You can find the paper reports for these students, their work there, as well as past students and their bios, and also any information about applying for the student grant program yourself as a undergraduate student looking into research and science. So thanks for watching.